In these problems, we're using the standard normal distribution to find z-values. So in all of these cases, we're going to assume that the mean is equal to 0 and the standard deviation is equal to 1. So whenever we're finding z-values, we know these two things because we're using this standard normal distribution. Okay, so in question 7, we want to find the z-score for which the area to the left is 0.03. So I draw my distribution. That's all right. And we want the area to the left to be 0.03. So the question is, what is this z-value if this area is 0.03? So I use the inverse norm function in the calculator, and I put in 0.03. Now, if you have a stat wizard, then you need to tell the wizard that the mean is 0 and the standard deviation is 1. And when you enter that, then you get negative 1.88. To get to inverse norm on your calculator, you press second and vars, and it'll be number 3 on that list. So that's how you do number 7. Now number 8, we want to find a z-score for which the area to the right is 0.04. So it's the same type of problem, but now the area is on the right side, so we're looking for this z-score, and the area is 0.04 in the right-hand tail. The calculator only finds the z-score for the area on the left. So in the previous problem, we had 0.03 on the left. In this case, the problem says that we have 0.04 on the right, which means that we have 0.96 on the left. So when I do this in the calculator, I do inverse norm of 0.96, and then of course the mean is 0, standard deviation is 1. If you don't have the stat wizard, you don't need to enter the 0 and 1. The calculator assumes that that's the default setting. And we get 1.75. So that's my answer for problem 8. Notice that this value is positive because we have a z-value on the right of the mean, and in the last problem our answer was negative because we had a z-value to the left of the mean. So of course the mean is 0, negatives on the left, positives on the right. So now let's take a look at question 9. In this problem, we want to find the z-scores, so 2 scores, that bound the middle 85% of the area under the standard normal curve. So here's my distribution. We want 85% to be in the middle. And that's centered in the middle, so that means that there is, let's see, 100 minus 85 gives me 15. So there's 15% left over, but there's 2 tails. So that means there's 7.5% in the right tail and 7.5% in the left tail, because I just take the 15 and divide it by 2 to get that 7.5%. So now I have 2 z-scores to find. Now here's the nice thing about this. I don't actually have to do 2 calculations because, again, we're working with the standard normal distribution, which is centered at 0, and it's symmetric. So whatever this value is it's going to be the same as this value, just opposite in sign. So the one on the left is going to be a negative number, the one on the right is going to be a positive number, but otherwise the number part of them is the same. So I'm going to do inverse norm. I'll find the value on the left, and I just have to do the inverse norm of 0.075. And of course put in the 0 and 1 if you need to do that for your calculator. So this gives me a negative 1.44. But that's not my final answer because I have two answers. So I have negative 1.44 and positive 1.44, and I can just write that as plus or minus 1.44. And that's my final answer. I could have done the calculation to get the right-hand value. I could have done inverse norm of, let's see, so then I'd have to find out what 85% plus 7.5% is, and that's 92.5%. So if I do this, I get positive 1.44. So there you go. So you can see that it wasn't really necessary to do that computation, but you could if you like to. So now for number 10, we have, let's see, it's the same problem again. Now we want to find the z-scores that bound the middle 94%. So you might want to pause this video and see if you can get this one all on your own. All right, give you a second to pause there. All right, so for middle 94%, I put my boundaries. So this is what I'm looking for. What's my left boundary? What's my right boundary? I know that there's 94% in the middle. 100% minus 94 gives me 6. And when I divide that into 2 because of the two tails, I get 3% in the top tail, 3% in the bottom tail, or the left tail and the right tail. Okay, so to find my answer, I'll just find the inverse norm of 0.03. But we actually did that before. We know that that comes out to be negative 1.88. So my final answer for this problem is plus or minus 1.88. Okay, so now for problems 11 and 12. This is the same type of problem we've been doing, but the notation is a little different. So for number 11, it asks us to find z sub 0.06. So that's how you read that. Z sub 0.06. And what this means is the z-score, which has an area of 0.06 to the right. So if I draw my sketch and I mark off 6%, so I'm looking for this z-score. Obviously it's positive because it's on the right-hand side of the mean. So I'm going to find inverse norm, and if there's 0.06 on the right, that means there's 0.94 on the left, and so we're going to do inverse norm of 0.94. Now I could skip that part. I don't really need to know about the 0.94. I could find inverse norm of 0.06, that's going to give me a negative answer, but otherwise it's a good answer, so I would just then take off the negative, and that's my answer. So here I put this in, I get 1.55. If I had done inverse norm of 0.06, I would have gotten negative 1.55, and then I just take the negative off of it, so there you go. So that's how we found z sub 0.06. In the next problem, we want to find z sub 0.12, So we'll do that the same. And I can even do this without drawing the sketch. The sketch isn't necessary. I find it helpful to kind of keep track of whether we're on the left or the right or what's going on. So I know that point 12 is the area to the right. That means the area to the left is 0.88. And of course, just as in the previous problem, I could have just put in inverse norm of 0.12, gotten a negative answer, and then taken the negative sign off of there. So here I get 1.17, and that's my final answer.